Hello everyone, I'm Valerio Terragni, a postdoc from the Università della Svizzera Italiana. I'm going to present our latest work on root-causing Flaky test. This is a joint work with Pasquale Salza from the University of Zurich and Filomena Ferrucci from the University of Salerno. Flaky tests are tests that pass or fail non-deterministically when executed on the same program version. Flaky tests are very harmful because test failure do not always indicate bugs in the code. Every time a test flakiness occurs, developers have to investigate whether the problem is in the production code, meaning that the test exposed a non-deterministic bug, or the problem is the test itself. In other words, they need to find the root cause of the flakiness, and this can be very time-consuming. Existing root cause analysis for test flakiness rely on execution logs obtained with code instrumentation. These approaches have three issues. First, they need to decide what to instrument, but this depends on the type of flakiness. That is something unknown in advance. Second, the use of instrumentation may prevent the manifestation of the flakiness. Third, they passively explore the non-deterministic space by re-executing the test many times, hoping that the flakiness will occur. Our new idea is a methodology for root-causing flaky tests that does not rely on any form of instrumentation and actively explores the non-deterministic space. Our idea is to execute a flaky test on different execution clusters. Each cluster explores a specific non-deterministic dimension that characterizes the type of flakiness. For example, concurrency, networking, or I/O. Based on how many times a test fails in each cluster, we can identify the most likely root cause. For instance, in this case, the flakiness happened only in the network cluster. Thus, we can infer with high confidence that the non-determinism of the network is the most likely root cause. More specifically, we envision a dedicated execution cluster for the most common types of test flakiness. Each execution cluster has associated a fuzzy loader that executes dummy operation on that perturbs the execution of the test, and also a container, a configuration that specifies the available resources. For example, the fuzzy loader of the multi-threaded cluster executes dummy operation on multiple threads for creating a resource contention, while the container configuration specifies the number of available cores. Every time a test executes on a cluster, we change the load of the fuzzy loader and the container configuration. This will actively explore the non-deterministic dimension associated to the cluster. After we execute the test, we can compare the failure rate with a baseline cluster that executes the test without perturbing the execution environment. We select as the root cause the cluster that has a failure rate that differs the most with respect to the failure rate of the baseline cluster. In this case, is the I/O cluster. That's all, and thank you for your attention.